This video is about quadratic function. For A, consider the function f of x equals a x minus p times x minus q, shown on the following graph. Find the equation of the axis of symmetry. From the graph, we know x1 equals -1 and x2 equals 8. Axis of symmetry, that will be x equals x1 plus x2 over 2. So you have a -1 plus 8 over 2. That is a 3.5. Therefore, x equals 3.5 will be the axis of symmetry. For 4b, find the value of p and of q. We know for this form, f of x equals a x minus p times x minus q. We call this is a factored form. This p and q, they are roots. Therefore, p equals -1 and q equals 8. Let's go to 4c. Find the value of a. Since we already figured out p equals -1 and q equals 8, we can write down the function f of x equals a times x minus -1, that is a +1, then times x minus 8. From the graph, we got this point. Let's label as a xy. So we plug into this function. You will get -4 equals a times x is 0. So 0 plus 1 is 1. 0 minus 8 is -8. So we get -4 equals -8a. Divided by -8 both sides, you will get a equals -4 over -8, that is 1 over 2. So a equals 1 over 2. Let's go to number 7. A factory produces shirts. The cost, say, in 肥件 dollars of producing X shirts can be modeled by say of X equals X minus 75 squared plus 100. Find the cost of producing 70 shirts. So we can get the C of 70 equals, change X into 70. 70 minus 75 squared plus 100 equals 125 FGD. Let's go to 7b. The cost of production shouldn't exceed 500 FGD. To do this, the factory needs to produce at least 55 shirts and at most S shirts. Find the value of S. According to this, the cost shouldn't exceed 500 FGD, which means C of X less than equal to 500. We need to solve this inequality. C of S, we know that is X minus 75 squared plus 100, less than or equal to 500. Since this is a quadratic function, let's move 500 to the left side. You will get X minus 75 squared plus 100 minus 500 less than or equal to 0. Combine like terms, you will get x minus 75 squared minus 400 less than or equal to 0. We will use a graphing calculator. We set up y1 equals x minus 75 squared minus 400. Since we are looking for less than or equal to 0, which means below x-axis, for which domain the graph is below x-axis, that will be the solution. Let's go to graphing calculator. So we will put x minus 75 squared minus 400. This is a standard window. We cannot see anything on the graph, so you need to change the window. We are looking for the roots. So go to this window. X minimum, X means shirts, so we get start from 0. Maximum, let's do 100 here. Scale is 10. 100 divided by 10 is 10. For the very beginning, you just need to guess the value. We can use 100. If this is still small, you can change into 200 and so on. For y minimum, we can use negative 100. This is the cost. Maximum, we can use 100. Scale will be 10. Then let's draw the graph. We want to check the vertex. We can change this window. For the y minimum, let's change it into negative 300. And scale, let's do 30 here. So graph. We still cannot see the vertex, so we need to change into, let's do negative 400. Y scale is 40 this time. Then graph. So you could see we graph this quadratic function with vertex and roots shown in this window. Then we can check these zeros. Second trace, go to 2. The unit x scale is 10. 10, 20, 30, 40. Let's do 40 as the left bound. Right bound, 50, 60. Let's do 60. Enter. Enter. So you get this 55. Then keep going. Second trace again. Go to 2. This is 80. Let's do 80 as left bound. And right bound, let's do 100. Then enter. You will get x equals 95. So when you produce the shirts between 55 and 95, the cost shouldn't exceed $500. Therefore, for this S equals 95. For number 7C, find the number of shirts produced when the cost of production is lowest. We do know from C of x equals x minus 75 squared plus 100. This is a vertex form. The vertex is 75 or 100. In other words, when we produce 75 shirts, the cost of the production is the lowest. So x equals 75 shirts. This will be the solution. Let's go to number 11. The graph of a quadratic function has a y-intercept 10, and one of its x-intercept is 1. The x-coordinate of the vertex of the graph is 3. The equation of the quadratic function is in the form of this one. Write down the value of c. We do know c is a y-intercept. So c equals 10. 11b, find the value of a and of b. From the given information, we already know y equals ax squared plus bx plus c. And on the graph, we know x-intercept is 1. We have a coordinate 1, 0. And also given the x coordinates of the vertex of the graph is 3, which means this h equals 3. So we have h equals 3. H, that is negative b over 2a. Or we can write down x1 plus x2 over 2. Since we are looking for the value of a and b, we can use this as the equation. First of all, let's plug in x equals 1, y equals 0 to this equation. We will get 0 equals a times 1 squared plus b times 1 plus 10. So we have a plus b plus 10 equals 0. This is the first equation. Second equation, let's use this. We have 3 equals negative b over 2a. Cross multiply, you will get 6a equals negative b. So b equals negative 6a. We have b equals negative 6a as the second equation. Since we have this pattern, we can use substitution to solve this system of equations. We plug b equals negative 6a to the first equation. You will get 0 equals a minus 6a plus 10. So we have negative 5a plus 10. This is a 0. Isolate the 5a on the left side. You will have 5a equals 10. So a equals 2. Then we plug in b equals negative 6. A here is 2. B equals negative 12. So we finish solving. A equals 2. B equals negative 12. Let's go to 11c. Write down the second x-intercept of the function. We got to use this formula. We know h equals 3. So 3 equals x1 plus x2 over 2. We are given x1 equals 1. So we get 1 plus x2 over 2. Cross multiply, 6 equals 1 plus x2. So x2 equals minus 1 both sides. That is a 5. This will be the second x-intercept.